Okay, in this video, we are going to analyze the linear function using a table of values. So I'm not going to go, I'm leaving this slide up so you can screenshot it or pause it and write these questions down. They will be the same questions that we will ask throughout all three of our representations of a function. Through a table of values, which we're going to do in this video, an equation, which we did in the last video, and then finally a graph, which we will do for the third video. So if you want to go through these questions in detail, I do that in the video about analyzing a word problem in the form of an equation, where they've given you an equation to be representative. Okay, so let's jump to the table of values. Okay, here's our scenario, and here's what we're given. So there's a swimming pool, and the swimming pool contains 55 gallons of water when Darius begins to fill it. Water flows into the pool at a constant rate, and I want to add per minute. The pool holds 1,000 gallons of water when it is full. Alrighty, well, let's start by just looking at what we've been given and start to label our axes, etc. So we know that when you start filling it, we've got 55 gallons of water. Okay, well, that sort of gives me a clue as to what my y-axis is going to be called. But here is the definite answer for what our independent variable is, what our slope is. Remember, the word per has to do with rate of change. It's a rate, something per something else, right? So since we don't know what the slope is, we're going to have to calculate it, but we do know that it's per minute. So that tells me that our x, our independent variable, is minutes. And which leaves our y, our dependent variable, to be gallons. And if you think about it, that makes sense. The number of gallons in the pool depend upon how long you fill it, right? The longer you fill it, the more gallons will go in. So our dependent variable is gallons. Cool. Got number one out of the way. Let's go to the next one. So what is the meaning of the y-intercept? Well, the y-intercept occurs when x equals 0. So you can look at our table of values and see, oh, when x is 0, y is 55. And if you look at the beginning of the problem, they say that the swimming pool contains 55 gallons of water when Darius begins to fill it. Well, that right there tells me that my y-intercept is 55. And what that means is that is the number of gallons when we started. Okay, cool. What about the x-intercept? Will there be an x-intercept in this problem? Well, if you think about it, do we have negative minutes? No. Is this an increasing or a decreasing function? Well, it's obviously increasing, right? Look at this. At 0 minutes, you've got 55 gallons. At 3 minutes, you've got 82 gallons. And at 4 minutes, you've got 91 gallons. You can clearly see that this starts at 55 and it just keeps going up. So no, we don't have to worry about the x-intercept in this problem. It doesn't tell us anything. We're not going to have one. So next, what is the slope of this function? And what does it represent in this problem? Well, let's take a look at this. In our last video that we did, when we were given an algebraic equation, well, the slope's right there. The slope is the coefficient of your x variable. But that's not the way that it is in this problem. That's not what they've given us. So we have to actually calculate it. All we have are 3 points. So let me just tell you, you can do this one of 2 ways. You can still do your subtracting your y's and subtracting your x's. And if you look right here, this is going to be easy because 4 minus 3 is 1. So we've got 91 minus 82 divided by 4 minus 3. So that gives 9 over 1, which is 9. Okay? But I also need you to understand that it is also possible and sometimes necessary. Sometimes they will not give you an opportunity for a unit rate right off the bat. You have to calculate it. So you also can do 82. You can do these 2 points. You can do 82 minus 55. And you can do 3 minus 0, right? And so you've got 12 minus 5 is 7. And 7 minus 5 is 2. So you've got 27 divided by 3. You know that when you have a slope, you have to reduce it. So you could still end up with 9, right? It's still the correct answer. So I just wanted to run through that for you so that you can clearly see that you can calculate your slope in more than one manner. All right. Next question. Oh, I'm sorry. I can't go to the next question yet because we're not done with this one. What does it represent? What does 9 represent? What are the units? It's gallons per minute, right? So 9 represents that we are filling the pool at a rate of 9 gallons per minute, which is pretty fast, to be honest. So is this function increasing or decreasing? Well, it seems pretty obvious that there are some words that clue you into the fact that this is an increasing function. There's the mathematical way to look at it, which is that 9 is a positive number. But there's also the idea that you're filling it. You're adding to it. Water flows into the pool. Okay, these things should be cluing you in to the idea that this is an increasing function. And then last but not least, what is our domain and range? So once again, we're going to pause for a minute so I can erase this, and then we'll go through that. Okay, so let's finish up. Our domain. Well, let's think about the fact that we're dealing with minutes. And when we start filling the pool, we're at 0 minutes, right? Well, we certainly can't do negative minutes. So just as in many real world functions, we are going to begin with 0. Okay? It's often the case. And then in this function, we don't go to infinity, do we? We can actually calculate how many minutes it'll be when the pool is full. So let's do that quickly. And if you use this, we got our slope. We could do point slope, but we don't have to because we have an initial value. So once we have our slope and an initial value, we can write our equation of the line in slope-intercept form. So that's 9x plus 55. Well, we can just set y equal to 1,000. So how many minutes does it take to get to 1,000 gallons? And if you do that math, you'll get a final answer of 105. Okay, so we know that we've got 105, bracket or parentheses. Well, the pool has 1,000 gallons in it when it's full. So this point, this coordinate, 105, is definitely a point on the line. So we're going to use a bracket. And if we were going to do this in inequality notation, well, all of our x's are in between these two endpoints, right? So we would have 0 is less than or equal to all the x's, and x is less than or equal to 105. Can't be greater than that because then the pool would be overflowing. So now let's talk about the range. Well, the range are all the possible y values. And we know that our graph starts at 0, and at 0, we begin at 55 gallons of water. So our lowest y value is 55. Once again, we know we have an endpoint this time. We know that we can go to 1,000. And just like with the time, we are going to put another bracket because the pool is allowed to have 1,000 gallons in it. So to finish up with inequality notation, all of our y's are going to be in between 55 and 1,000. There you go. See you in the next video.